Hi, welcome to Up Top Solar. My name is Gwendolyn Espy, and I will be walking you through this MATE3 or MATE3s data logging, how to read the data logs to better help you to troubleshoot. So I used to work at OutBack Power, so I have a little bit of a technical background with their products. And specifically with data logging, a lot of times I've heard on tech support, can you start data logging so we can get some information, see exactly what the system is doing? If I can teach you how to do that, then maybe you could troubleshoot it yourself or, not have to wait in line to get help from a tech support person. And you can be more self-sustainable or self-supporting. All right. So let's get started. This will be kind of informal, nitty gritty. I just realized I'm wearing two watches. Nitty gritty of MATE3 data logging. So we're just gonna walk through this. What I will show you is not necessarily the only way to do this, but it's I'll teach you how I would do it. And I might change my mind how I do it. We'll see how it happens. But hopefully it gives you enough information so that you can, what you're looking at and you can just do it however you want to do it. All right. So let's get started. First is if you don't know how to data log, what you need is an SD card and then a MATE3 or MATE3s and program the MATE3 to data log. Data logging is a MATE3 or MATE3s function or feature. So you have to make sure that you do have a MATE3s and then initiate it. If you don't know how to do that, there is, my screen's over here, so you'll be seeing me looking this way. If you don't know how to do that, there's already a video, and actually a couple videos that I found, but this one's at OutBack Power, their channel, and they have tech support, MATE3 data logging, and how to initiate it. So if you don't know how to do that, there's already information on that. I'm not going to cover it here. With that said, let's start. First is this applications note. This you can find in OutBack Power's website under their, I think it's called application notes under communications. Let me just show you how to do that. Layout. I don't know if I've even clicked the other two. I just go directly to installers. Okay, so you go to resources, product, application notes. Click that. My computer's really slow. Because the MATE3 is a system management, it's not an inverter charge controller, we go there and you click the MATE3 class system display data logging references. And that's what you see here. All right. Let me show you what this document is, and we'll go through it as I organize the data logs. So we'll become more familiar with this together. And all right, so this is the FX class. So there's going to be a different section depending on the product that you have or the device. So this is the FX class. So this would be FX, FXRs. Those are the inverters. There's also, and this shows you what the headers are here, what they mean. You'll need this when you organize your data, and then descriptions on everything. And then next will be, let's see, this next one would be a Radian. So the FXR and Radian are different devices, and they're identified as such. You can see here, this is device type 6. So if you see something with a device type 6, that means it's a Radian that you're looking at. The FX, I think, is 2. Let's see what it is. Device type 2 here. So yeah, so if you see a 2, that means you're looking at an FXR or FX. And so on. So there's like a charge controller one. Here it is. Device type 3. All right, so we'll be referencing this. So I recommend going through this and reading it and seeing what it looks like. And just so you know what you're looking at, and it gives you some background in case I'm not covering everything. my focus here is how to read the data logs and how to interpret the more complicated portions of it that might not be as intuitive. All right, so let's go look at a data log. All right, so what I have here is these headers already done. You know, you can just make this yourself. It's not really that difficult. You just go through the document and you can just create this. So I have these so I can just copy and paste them when I do data logging or if I look at data logs. And so we'll be using that later. Here is an example of, here's an example of what a data log might look like. The name here is 17010100. This is a specific name reference, and this is basically the date and time. So I believe it's year, month, day, and then the time. And the time is going to be per hour. So each file will be representing an hour of data. And it's in military time. So if this is 00, it's midnight. And if it's, for example, 06, it's 6 a.m. If it's 21, it'll be, I think, 9 p.m., etc. So you kind of know what you're looking at when you see this file naming format. And you can see that the date and time over here as well. All right. So what I'm going to do is this is how I would do it. Actually, in the past, I've done it differently. And what I would do, and it just depends on your preference. I used to create a different tab for each device. I would have a charge controller tab, FNDC tab, an inverter tab, and separate the data that way. But sometimes it's nice to have the option to see it all in one page, just in case, you know, it's a systematic issue or something systematically you don't know exactly what you're looking for. So what I'm going to do, and like I said, there's different ways to do this. What I'm going to do is I'm going to first identify, because I already know that this is, these are the device types. So it looks like I have 6, 3, and 4. So that means I have 3 devices, 6, 3, and 4. I'm going to copy and paste those headers here. So let's see. Like I said, you get these headers from that document I showed you. So we have device type 6 here. So I'm going to copy this. That means we have a Radian. Ooh, that's not what I want. Okay. That's what I want. Okay, so we have our device type 6. Device type 3 means we have a charge controller. So I'm going to copy the headers for that and paste it. Okay. And last but not least is device type 4, which I believe is an FNDC. No. Oh yeah, 4. FNDC. Yes. Yeah. Okay. Yeah, okay. So what I'm going to do, this is just a formatting thing. I'm just going to highlight all this, right click, format cells. I'm going to move the titles to be vertical so that it's a little bit easier to see, to read those headers. Okay, I'm going to edit some of this waiting time. My computer's really slow, so I'm going to cut the waiting time to make this video a little bit faster. All right, so now we're going to do this alignment. Essentially want it at 90 here. So now they're vertical. Great. Oh, this one looks weird. So everything looks good. Okay. This is the part where I'm going to now apply a filter to the top row so that we can filter our data and header. When I do this, it's going to keep that first row, because that's our filter row, there at all times. So when you're not looking at device type 6, which is a Radian, you'll see this. This will still be there because it's our filter row. I'm sure you could just add another row and just put like X's or something like that. Because for some reason you can only filter rows that have a value there. Yeah, I can show you. So we're gonna do. Okay, no, let's just do it. I'll show you. Okay, so I'm just gonna put an X because for some reason. It won't do it if unless there's a value. Okay, delete it. All right, so I'm going to highlight this and we're going to click auto filter. All right, great. So now I have this filter here. And what we can do now is we can now filter based on device type. So if you just want to look and troubleshoot your inverter, your Radian inverter, and like I said, if these were blanks, it didn't work for me. It might work, and this is not Excel, it's LibreOffice Calc. It could work in Excel. You can try that and just leave this row blank. I've tried that. You have to have a value in there, so I'm just putting a placeholder there, X. But we're not really using this row just for filtering. We're just using it for filtering. Okay, so let's say we want to look at just the Radian system here. We can go, I'm going to make this a little bit wider. Okay, so we can go to this top row. We know that the Radian is device type 6. So we are going to filter by device type. That's this data here. And then we want to keep this header. So these are the headers here, device type 6. And that should leave, there you go. That should leave this header here, and then all of the data for that unit or for that device type. Okay, but you can see this didn't affect the first row. The first row is there just for filtering. All right, so now let's take a look at what all of this means. I'm going to now move this to the right here. This here, our handy dandy app note. Okay, so this is the Radian. So we have the Radian class inverter data stream. So this is our key to read this. Like I said, you can get the headers from here and just put them in manually. It's not a big deal. You can make yourself a file where you did do it manually. You can make yourself a file that you can just use and copy and paste, just like how I just did. That's one way to do it. And all right, so let's go through this. So we have date, time, port. So it looks like our Radian is connected to port 1. You'll see in the other devices, it will show what port which port you're looking at. So if you had multiple Radians, for example, you will know, and one Radian is acting up or one Radian isn't behaving, or you're just interested in one Radian, you can not only filter this by device type. So if you had multiple Radians, you'll have, all of them here when you filter it this way. And then you can isolate it even further depending on what port you want. So if there were multiple Radians here, you could click, this is the one I want to know. And then if you don't know which one you want, and you see an issue, you can go back and see which port Radian is that we're looking at. So that's nice. All right, so we have our port, we have our device type. This stuff is kind of intuitive. So it's your inverter current. You have your L1, L2, this is a split phase Radian inverter. So you have your L1, L2 information, current voltage, input, output. And now here, we're going to skip to S here. Let me make this a little bit bigger. So the inverter operating mode, error code, AC mode, miscellaneous, warning code. This is where things get a little bit more interesting and where you might be looking if you are troubleshooting. So let's look at the Radian operating mode. We have 10 here. So the inverter operating mode is 10. So let's take a look at this chart. So in this application note, it shows you what the inverter is operating under. So we look at 10 here, we see it's in pass-through mode. It's in pass-through mode, so you have L1 by current is 9 amps, so that's going straight to your loads. It's in pass-through mode, so that's what it's doing. And then the inverter is technically not inverting. It's not inverting because it's just a piece of wire in pass-through mode. So it's not inverting, so that's going to be 0. So you just know that it's just going directly to your loads. So it's getting 9 amps. It's buying 9 amps in L1 and buying 2 amps on L2. And because it's this 10, you know it's in pass-through mode. So there you go. Let's go to the next one. So if it wasn't 10, if it was like supporting or if it was a slave and it was off, it would show a 12. You've had multiple inverters. Yeah, so this will tell you exactly what the Radian's operating mode was at that time, which could be really helpful. If you thought the inverter should be charging at that time and it's not, this will tell you that exactly what was happening, what was the inverter thinking it should be doing, and what was it doing. All right. The next one is error code. This one is a little bit interesting. So, okay. So you could, some of these you probably couldn't have at the same time. For example, like low battery, high battery, you shouldn't be able to have that at the same time. But it's possible you could have multiple errors at the same time. And right now our errors are 0, so there's no errors in this. But let's say you had a high battery and over temp, then the code here, the number presented here would be 32 plus 4. And that would be that would be 36. So the number here would be 36, and that's unique. Like there's no other way you could get the number 36 besides those 2 errors. So by doing the math, you should be able to figure out, okay, what errors is this presenting? So if there's multiple errors, for example, 32 and 4 is 96. So if you had a high battery and a shorted output, you'll see 96, and you can just look at this table, and there's no other way you could get that number besides those 2 faults. And that's how you read that. So for error codes, you could have multiple errors at the same time. So you just have to see what number is being presented. And is that 1 error or is that multiple errors? And if it's multiple errors, which ones are they? The next one is Radian AC modes. This is mutually exclusive. It is, you can only have 1 happening at the same time, not like errors. You could have multiple. So it'd be 0, 1, or 2. It looks like this is 2. So it is AC use. That makes sense because it is buying power from the grid and passing it through. So that tracks. Last but not least is Radian miscellaneous. This works the same way as the error codes. So you could have multiple happening at the same time, and you just have to do the math to figure out which ones are they. This one is 12, which means the only way to get that would be this 4 and 8, and they're reserved by the inverter. So we don't know what's happening there. That's behind engineering's curtain. And warning codes. So let's look. Right now we don't have any warning codes. But if we did, let's see. Yeah, so this would operate the same way as before. Like if there are, multiple warnings, then you'd have to do the math. So if there was a sensor failed, a phase loss, and a phase loss, right, you'd get 96. If there was a high frequency temperature sensor failed and a phase loss, you'd get 97. And there's no other way you could have gotten there. And that's how this works. So that's it's mostly these tables that I wanted to explain what you're looking at and how that works, and also like how to lay this out. I think we kind of covered a lot of what I wanted to share. We'll quickly go over the charge controller, and then the FNDC has something a little special with that as well, so we'll cover that. All right, so the next will be the charge controller. So I'll go to my top row here, and I know charge controller is 3, so I'm going to unclick 6, unclick device type 6. This is that header, and I'm going to click 3 so it can filter the data, and then click device type 3 to click that header that's associated with that. All right, so now we have our charge controller headers and our charge controller data. And this data here is just for that hour. So you're going to get a new CSV for each hour of data. Whether the interval is, every second, every 5 seconds, it's just going to be at an hour at a time. All right, so we have our 3. So let's go here to our document and find our, okay, I think it's after the Radian. Find our information so we can make sure that we can go over everything correctly. Okay, our charge controller. So charge controller is device type 3, so we're in the right place. It's very similar to a lot of it's similar or intuitive. So we have date, time, port. This charge controller is at port 9. You're probably more likely to have more charge controllers than inverters. So if you had multiple charge controllers, you can differentiate which charge controller am I looking at by looking at the port. And all right, so we have device type 3, which is a charge controller, unused. That's helpful. Charge current, PV voltage, daily kilowatt hours. Oh, that's interesting. And then we have charge controller amps in tenths. So I think this is that charge controller current in total amps, and then you have your tenths unit here. Then we have our auxiliary mode, air code mode, battery voltage, and amp hours. Let's check out this first, and then we'll go over the tables. So the battery voltage is, let's go to daily kilowatts. Okay, kilowatt hours, we'll work our way. So the kilowatt hours harvested by the controller that day. For example, a harvest of 55.5 kilowatt hours will be sent as 555. So what that means is that, so we have this 94 here, so we need to put a decimal point here. So it's 9.4 kilowatt hours harvested that day. And so we need to make sure that we do that. And the same thing, we'll just jump to battery voltage. It's the same concept for battery voltage. This says 46.8, and what that really is 40. It says 468. What it means is 46.8. So you need to put that decimal point there. Okay, and so let's see, and then let's go over the charge current actually too. All right, measures DC current delivered from the controller output to the batteries. The range is 0 to 99, increments of 1 ampere. So this is just 1 ampere at a time. A separate item measures the tenths of an amp. All right, so then we know that we are doing, let's see. Oh, it's nighttime. It's midnight. We don't have any current. But if this was 5 and this was 3, it would be 5.3 amps essentially. All right, now let's go to the more interesting portions, and this is the aux mode. So charge controllers have an auxiliary And this also, the data logging records what is what the auxiliary is operating under and whether it's enabled or disabled. So let's go over that. So aux mode is 3. Okay, so we have a column here of disabled, which is 00 to 10, and then enabled, which is 64 to 74. So if you have, so if this is 3, that means that this is a manual aux mode and it is currently disabled. If we had like a low battery, you were utilizing the low battery function, then it being disabled would be 10, and if it was enabled, it would be 74. So the number not only tells you which mode you're using currently, but it also tells you whether it's enabled or disabled. So hopefully that makes sense. All right, charge controller fault codes. This is similar to what we talked about before, adding them up. If you had all 3 faults, it would be the total sum of all 3 of these. If you only had one, and it's unique. If you only had one, you'll see 32 if there was a shorted battery sensor. You'll see 96 if there's both of these, etc. Looks like right now we are 0, so there's zero error codes or fault codes, which is good. And then charger mode, 0. We have silent, float, bulk, absorb, equalize. I believe this would probably be 0 silent. Yeah, because it's nighttime. There's nothing happening. It's boring. Yeah, so we have silent here, so that makes sense as well. Amp hours, that's self-explanatory. So yeah, I think that's the charge controller. Now let's go to the FNDC. So I'm going to go back up here to our filter. I'm going to unclick, and then we're going to do 4. 4 is the FNDC. So I'll click 4 so we can filter the data for just the FNDC, and then click device type 4, and that will give us the FNDC headers. And then we're going to go here, go to our documentation. Okay. All right, so we have a date, time, port, device type, shunt A amps, shunt B amps, shunt C amps. This is the current at that time that shunt is seeing. Extra identifier. This is complicated. It doesn't have to be as complicated, but it's not super intuitive, and I will explain that one later. So the extra data identifier and extra data. Then we have our battery voltage, same as the charge controller and the inverter. It's just, it's presented as 476. It's really 47.6 volts. We have our state or charge. Let's see what this says. I think it's intuitive, but just to make sure we're getting this right. Yeah, so it's this one. The state of charge as determined by the program parameters of the FlexNet DC, the range is 0 to 100%. Okay, so it's just a state of charge. So how full are the batteries? So right now they are 89% state of charge. Shunt enable. We'll go over that. Status flag. Okay, and battery temp. Let's see what this says. The temperature batteries reported by the RTS ranges 00 to 70. This represents degrees Celsius. Okay, that is 10 less than the value shown. Okay, what does that mean? This represents a range of degrees Celsius that is 10 less than the value shown. The result is a range of negative 10 degrees Celsius to 60 degrees Celsius. Got it. A value of 99 indicates that there's no RTS. Okay, so that's somewhat confusing. So this is basically saying 00 represents negative 10 and 70 represents 60. So you just have to subtract 10 from what's presented, and that's the degrees in Celsius. so let's take a look. So this is saying then it is 27 degrees Celsius at that time. Okay. All right. I'm glad we went over that because I don't think I knew that. All right. So we're going to do the status flag. So right now it's 8 and then 40. Okay. So looks like we're getting status flag. So let's take a look at what this means. There are 6 individual values displayed in values ranging from 000 to 255. Each value is a flag for a different function as shown in table 19. Okay, so it looks like it's jumping. Oh, wow, it's jumping all over the place. 8. Shunt A values are negative. Okay. So, okay, we have to go through shunt enable as well. We'll go over it. Okay, so it looks like 8 is shunt A values are negative. 40 would be the combination. No, 40 would be shunt A values and shunt C values are negative because 8 plus 32 is 40. 24 would be 16 and 8. So at some point it's just this is negative, then these two are negative, and then now these two are negative. So I bet they're all just negative. 56 is new. Make me do math. Okay, so that's these two are negative. So it's just jumping between saying that shunt A, B, and C are negative values. Okay. This could actually be helpful sometimes because the sometimes I've seen people wiring the shunts incorrectly, backwards essentially, and it can give really weird results for state of charge because you think you're charging, it is charging, and it's actually reading as if it's discharging. So this could be helpful information, understanding like, oh, okay, what's the flow? How should this look like? Because let's see, technically, you should have depending on what the status is. If, for example, if you're charging from PV and the grid, you might have like the opposite. Let's see. No, it would both be positive because positive is going into the batteries and then negative is leaving the battery. So from the PV to the batteries is always going to be positive. And then from between the battery and the inverter, it could be positive if you're charging, and then it would be negative when you're pulling. But you could also have DC loads or DC generator. It just depends on how your system's set up. But this could be an indication that, that either something is pulling energy from the battery that you didn't expect, or it's wired wrong, or there's a leak, etc. All right. So that's the status flag. Now, so we have that. Okay, so now let's go to these guys here. Hopefully I can explain this. Okay. All right. So first we have our extra identifier. I'll just read it from the document. I think, hey, I'm the one who last updated this. Okay. So, let's just read it from the document because that might be the best way to say this. So the extra data identifier, this is a data stream. This data stream reflects the data that typically changes very slowly. The column provides an identifier for the type of data appearing in the next column. So it tells you what type of data and then the data itself. And the reason that they just use one column is because it changes so slowly that, having recorded it, you don't need that data every 5 seconds. So it just alternates between the types of data that you're seeing. The total additive value from 0 to 63 can be determined from the type section on table 18. All right, so, and I'll explain the sign portion. let's just read it. The sign section of table 18 adds 64 to the type to indicate a negative extra data value. If the identifier is over 64, subtract 64 before determining the additive value in table 18. Make certain to note that the extra data is a negative number. All right, so what that means is that if it's over 64, if it's 64 or higher, it is a negative number, that data. And you have to subtract 64 to figure out what type it is. Ooh, I'm losing my voice. All right, so we will go over the first few ones, all right, so you can see, because it looks like we have to do a couple different types here. Okay, so the first one is going to be 6. Okay, so 6 is going to be positive because it's below 64, so it's days since full battery. So then we have here 982 days, essentially. Wow. Since full battery. Is that what that means, though? I think it is. Oh, no, since full output. Okay. That's why you got to look at the documentation here. Okay. Since full output. Okay. 7 is today's minimum state of charge, which is 88%. Let's see, 8 is today's net input in amp hours. Let's just jump to 76. So we have here 76 is greater than 64, right? So you have to subtract 64 from that. Okay, so you have to subtract 64 from that, which is 12. So now we just have to keep in mind that data is negative, okay? But this identifier is 12. So then here it's charge factor corrected net battery amp hours. So then this is negative 39. If we jump to 64, 64 is minus 64. We know this is a negative number, is 0. So that means that here this is type 0. Accumulated amp hours shunt A. So this is a negative 106 amp hours accumulated net on shunt A at this time. Yeah, so this is how you read this one. So it's just a data stream. So it's different, each identifier is a different piece of data, and then if it's higher, if it's higher than 64 or higher, it's indicating a negative number. Yeah. So hopefully that's not too confusing. And I think that was the most confusing part of all of this. So yeah, I think that's it. If you want to combine, because when you go to your SD card, and you're going to see like a bunch of files. One is for each hour, so you might have to copy and paste all of your data. So that you have like a continuous flow between, several hours or a day, and you can, do some more troubleshooting. It just depends on how fast your computer might be. Maybe that's not ideal. You have a slow computer, you already know what hour you're having the issue, so you can just look at the specific hour that you're seeing it, or combine a few hours together. I'm just looking at one piece of data just so you can better understand or see everything and how it works. So there's also a possibility, right, so that you can see everything. So let's just click everything. Let's say it's a system and you're like, okay, why is the charge controller doing what it's doing? Like sometimes, for example, I don't have it here, but for example, like the charge controller might terminate before you thought it should and the inverter is charging. So essentially it's, not prioritizing the charge controller, it's prioritizing the inverter. And sometimes it happens because you set your charge control settings lower than the inverter. So the inverter, it gets priority when it charges. And you can see that all here. You can see, okay, well, when did the charge controller become silent? Oh, it became silent, 2 volts before the inverter did. What is the inverter doing? And you can see all the different modes. and see what the battery voltage is. What does the charge controller think the battery voltage is? What does the inverter think the battery voltage is? Okay, well, there's some discrepancy there. So I need to make an adjustment, on the charge controller or the inverter. Maybe there's longer wire, so there's some a voltage drop between the charge controller and the battery that's giving an inaccurate reading. So there's a lot of powerful information here that you could use to maybe troubleshoot your system. Specifically the error codes, battery voltage. A lot of times, people are like, hey, my inverter shut down. Why did it do that? Probably, a lot of times it's because the system wasn't sized right, or because you programmed it wrong. Not necessarily programmed it wrong, but you programmed it in a way that's not benefiting the application or what you wanted it to do. So this data logging will show you that. Like I said, sometimes like an inverter shuts down early, you can see, hey, you hit your low battery cutoff. That's why. Either your battery cutoff is too low, or your batteries aren't big enough and you're getting to that point really fast. The inverter's operating as it should, or, it could be high temperature. Your unit is getting too hot, and so it has to shut down in order to cool down. You can get temperature data and stuff like that. So this data logging is really useful, especially because you're also getting it from the device's perspective. So it's giving you exactly what the device thinks it should be doing and what it's reading at the time. And like I said, voltage, capacity, temperature, error codes, warnings. These are the places that I usually look for when troubleshooting. There's also a configuration file that you can get. I won't cover that in this video, but this data logging in conjunction with the it's like a file that gives you all the settings. You can kind of see like, okay, what is it doing and what did I program it to do? And with those two files, you can kind of like most of the time troubleshoot and say, okay, this is the discrepancy here. So hopefully quick, or not. But this is how you do data logging, or how you view data logging. So I hope this was helpful. I should wrap this up so it's not super long. If you have any questions, feel free to comment and below. I can try to make like a quick start version of this. I just kind of, threw this together just because I have somebody who really needs a video like this. So hopefully this was helpful. All right. Thanks. Bye.